this new lecture on applied ergonomics, lecture 11. This lecture is intended mostly on industrial safety, studying accidents and human errors and what are the causes. So we are going to do a taxonomy, sort of an organized classification of how you can involve various components which we have discussed earlier related to work systems and their corresponding involvement in creating unsafe work practices which could be avoided. Okay, and in case of certain unsafe work practices, we can classify them as human accidents or maybe even accidents related to equipments or methods. So let's talk about industrial safety. So the first thing I would like to emphasize here is a sort of a need finding step as to why safety is quite important in almost daily life experience of work systems. So each day an average of about 16 workers die from injury that occurs during working, and this is only the data related to the OSHA, the Occupational Health and Safety Agency, and this is not a global data. So obviously this is more data for United States, and it can probably spread across the globe. This number will definitely increase because of that. So these deaths, if we look at and the kind of cost that the society would have, the cost impact the society of have, apart from the obviously the emotional value and the and the value related to the family support system, more than about $100 billion per year is spent in certain such personal tragedies related to workers dying at work. Okay, and there's so many families involved. So obviously this is not very good practice that can be sustained, and so definitely we need to develop zero tolerance systems as far as occupational safety is concerned and occupational hazards are concerned, and you want to develop systems which are very safe, possibly with a foolproofing step, so that there is no recurrence of any major event which leads to casualties among the various stakeholders related to a work system. So each day an average of about 9,000 workers in US alone suffer injuries on the job, apart from these deaths which are actually fatal casualties. And there are obviously many fallouts, including work days which are lost because of such occupational injuries. And if we looked at the number of work days alone in the United States from the OSHA data, it is close to about 50 million per year, that such kind of work days are lost primarily because of occupational injuries. So each day an average of about 137 worker dies from work related diseases. Okay, so this could be so this is slightly different than workers dying of injury, where actively some accident has taken place. Okay, so people particularly working in hazardous industries, exposed to chemicals, let's say working within mines or some areas related to excavation, they do have a lot of fallout in terms of post job infection or diseases, which again are quite fatal. So this could also be in a way linked to the occupational safety domain. So we see that from the statistics that the total amount of information which is there on all these point out that there is a very important need of maintaining safe practices and safe methods, so that such casualties from injuries or work related diseases or even injuries which could be fatal should be by and large avoided, while designing by making the system itself a robust design with mostly foolproofed kind of mechanisms, so that such occupational safety is enhanced. So let's look at industrial accidents. So unexpected and unintentional events that disrupt work procedures and have a potential to cause damage to property and injury or death to the workers can be classified as the definition for industrial accidents. And we can further classify an accident into two different types, one which actually causes damage, injury or death, and another which has only the potential of having these consequences. So basically something which is of a preventive sort of strategy has to be followed in one case to identify which has happened post occurrence, and another case to sort of proactively do it in identical situations which may otherwise happen if the process is out of control. So therefore you want to create in one cases a study group which looks at the existing work systems and finds out potential sources of creating damage or injury or death to the worker subjects associated with the system, and another one which actually on a case to case basis after the activity has been carried out or an accident has occurred do the investigation. So these are the two separate routes which you should try to follow when we talk about studying of industrial accidents. So the objective in occupational safety is really to reduce the incidence of accidents, and that can be also done by reducing the hazards that precipitate from them. Obviously if I wanted to define hazards in more appropriate term, it's a condition or set of conditions that has potential of causing an accident or other harmful outcome, and the danger posed by such a hazard could be something like relative exposure or liability to injury. It could cause death, it could cause damage from a hazard which otherwise you don't know while you're doing the job that is causing this damage, but there may be later on consequences. For example, look at the problem of silicosis which happened to people in asbestos industries working for asbestos systems. So people realized later that the lung infections that they were getting and the other breathing issues that they were getting were typically from deposited silica in the small capillaries within the lung. So these are some of the dangers which you really don't realize once the system is in place and people are associated with the system, but then there may be fallouts. There are other kind of potential dangers being posed by a hazard which is otherwise not making an accident happen because probably the system is more compliant. For example, let's look at a railroad crossing, and typically any railroad crossing is a hazard because it's about a crisscross of road traffic and rail traffic, and if a signaling system is not properly maintained or people don't pay more attention to it, there can be, it doesn't take a minute for the hazard to come up in terms of a fatal accident. So such systems where there is some degree of hazard being always posed and it is made under control have to be enforced so much in terms of the control and more attention, and has to be more automated in a manner so that such foolproofings will result in very less accidents and fatalities. So the organized study of such occupational hazards becomes a sort of a precondition for laying out any work system and for again maintaining and carrying out activities associated with the work system. So let's look at some data. So if we look at frequencies of the fatal injuries per 100,000 workers, let's say, in different industries, and this is data pertaining particularly to the United States again. If I had, let's say, mining industry, there are about close to 23.5 workers per 10,000 workers who have had fatal injuries, so it's one of the highest. Obviously mining is quite a bit of challenging task where the environment that the people would work in is typically very hazardous, very unpredictable. You don't know how the earth crusts where some of these minerals have been excavated from behave. It's having a high degree of randomness, so nothing can be predicted. There is also a lot of fatality in the agricultural sector. About 22.7 per 100,000 workers suffer through such fatal injuries, particularly in agriculture sector. In the construction sector, this number is about 12.2. Transportation, it's about 11.3. Manufacturing sector still is in quite a bit of control because you can design work systems where external influence of environment may not be that great. You see, for example, in the first 4 types where this number is very high, there is a substantial influence played by the environment in which the operators work. And in manufacturing, the advantage is that it's a controlled system where we can, if we wish so and if we desire so, try to make it as much unresponsive to environmental changes or challenges, so that there can be a steadiness in terms of whatever has been laid out on the work system. So there are about 2.4 per 10,000 workers in the wholesale retail business, 1.7 in the services business, and finance, insurance or real estate is very small, about 1 in 10,000, 100,000 workers. So this looks at some numbers associated with what kind of fatal injuries, or what are the numbers of fatal injuries which may happen in a sectorial manner. If we wanted to look at the non-fatal injuries, they crop up only for about per 100 workers, and they are quite high in number, because these are probably the ones where not very significant amount of attention is posed by the administration, or let's say the designer, because these are probably due to non-compliance mostly of the workers in terms of ability to fail on doing certain routine tasks because of the repetitive nature of the task, attention disorder, so on and so forth. So if we look at these numbers are for any 100 workers, and in construction such non-fatal injuries could be about as high as 6.9, similarly manufacturing about 6.4, agricultural 6.0. So I see, you see in this particular sector, in the mining area, the non-fatal injuries are quite less in comparison to the fatal injuries, okay, of course over a large number of workers, but it does indicate what are those sectors which really are very concerning in terms of fatal injuries, where the non-fatal injury may not be so much in comparison to the other sectors, okay. And it really emerges as a theory that wherever there is a significant environmental influence on the system, the fatality increases, okay, in comparison to what we can record as non-fatal injuries. So we also have a sort of classification based on what are different causes of workplace deaths and injuries. For example, the injuries could be typically related to overexertion, and because of overexertion, non-compliance to some routinely followed processes and systems. It could be because of impact accidents, it could be because of falls from tall structures, it could be because some chemicals may bodily react, which is true for those people who are working in hazardous chemical environments. It could be due to compression, it could be due to motor vehicle accidents, it could also be due to exposure to radiations and caustics. This is a major problem in the nuclear industry. It could also be the injury could come from various rubbing and abrasions, which may be while manufacturing something, or maybe even if somebody has not paid enough attention, there is a chance of such rubbing and abrasions almost always. Could be exposure to extreme temperatures. So these are different causes which could cause injuries, whereas the causes mostly where there is almost immediate fatal injury and death could happen due to motor vehicle related accidents, big falls, where the falls may result in such fatal injuries. It could result to high voltages, high currents, people who suffer severe shocks from such systems. Could happen because of drowning, could happen because of burning, particularly to fire related activities or fire related events. It could happen due to crashes, etc., associated with machines unable to fly. So all air transport related casualties, and a majority of them do convert into fatal injuries. It could happen due to some kind of poison. This could be mediated through consumption of either fluid or even breathing. Such poison can come into picture because of some non-compliance, again related to a chemical industry or related to some bad consequence. For example, we know of a recent case where there was a closed automobile which was placed for a long time under the sun, and because of toxic fumes which generated from the plastic components of within the automobile and the paint, there was a death of an infant who was transported into the automobile without proper bleeding of the internal cabin air. So these would result in some fatalities. So again, there are deaths related to water transport or some other means. Okay, so these are some classifications, or these are some sort of causes that one can think of to classify events which might be leading to fatal injuries, leading to death, or just injuries which could be treated. So if we look at the cause of industrial accidents, so there are typically three different classifications why accidents must happen. One is because of human errors. Okay, then there can be something related to the job factors. Some jobs are more dangerous than others, and then obviously any factor which is associated with such a job, including the method of doing a job, materials which are involved in the job, or equipments which are involved in the job, are individually causes of such non-compliances where there would be safety issues propping up. There are also environmental factors which sometimes come. For example, look at lightning to an airplane, what kind of damage it may do. So the airplane is not enabled to handle the lightning, it could cause into an airplane fire while in operation. There could be a very big noise which could cause deafening. Okay, so there are guidelines associated with such noises. So there are environmental factors also which would cause such industrial accidents from happening. So typically, if I looked at all the organizational variables and management policies which are in the area of occupational safety, they can be categorized as factors related to human errors, factors related to the job design itself, or factors related to the environmental condition. And all these factors do pose something called a hazardous situation or a condition which can lead to an accident, which may perchance not lead to an accident, and it could be a chance cause as well. But then there is a possibility of getting into this domain, and therefore it's important to organize and classify the knowledge in these particular areas so that we avoid most of these unpleasant industrial accidents from happening. So let's actually look at now these individual factors and try to see what are the different issues involved in such work systems which can cause human errors, or for example non-compliance to all these job factors or environmental conditions. So when we talk about human errors, it's really a misnomer. It cannot be completely a human error, and the error may typically happen because of challenges like poor design of a system, or maybe even poor practices of management. For example, let's say a worker is overexerted by putting into more than one shifts without giving him enough rest time in between. So these kind of things may always happen as bad administrative practices which may create overburdening, and then not because of the overburdening issue, not following of certain laid out guidelines, particularly for repetitive tasks, okay, which may result in some human errors. And then also it can be violations of use and maintenance of equipments which may generally lead to the unsafe practices. So errors usually are really triggered by other things. It may not be that, so even if we are calling it human error, it may not mean that it is related to the concerned human being. It may be a n number of reasons because of which an error has happened, because otherwise a human subject is the most intelligent subject and prudent to take the right decision at the right time in a very quick let's say time cycle, involving a very quick time unit. So generally the human errors would happen because of some other causes. So error is the end result of some of these problems, okay. I just indicated these problems in the last step here. For example, if we look at airplane accidents, the pilot error is only about 70% of all such accidents, okay, or the operator error blamed on over 60% of nuclear power plant accidents. Or for example, errors done by doctors or nurses in ICUs occur at the rate of about 1.7 patients per day. So if we looked at such data, it does indicates that 30% of the cases it's because of the machine problem, right? The airplane itself was a problem, or in this particular case about 40% of the accidents happened because there were problems related to the power plants and the safety measures which are involved in it. So obviously there is some operator judgment which may be a source of an error, but then there are a lot of other factors which contribute to augmenting this human error. So if we wanted to classify the different types of human errors, so we can actually outlay them in two different broad categories. One is called the error of omissions, which means that the operator fails to perform certain procedural step because of which an error happens, leading to such an event, such an accident event. And then there can be an error of commission, where the operator performs an extra duty or extra step and performs it incorrectly, okay. And so because of such performance adding extra work but in an incorrect manner, there may be a possibility that there is a human error. So this is actually more related to the cognitive aspect or the knowledge domain, let us say, of an operator, and you have to classify this whole business of errors into a very organized manner as to where it is cropping up from a knowledge domain or where it is cropping up from a let us say a rule which you are using but following it wrongly, and then where it is happening because of a slip. For example, those work elements where the typical operator will say, oops, I did something wrong. So those kind of issues have to be classified in different contexts, so that I can have a good standard way of looking at the sources of generation of such human errors. So let us look at the taxonomy of the human errors. So we see that there is a stimulus which is an evidence for us to sort of start analyzing a situation which has happened or arrived at which is unsafe. And so first of all, we if we have this stimulus, we will start acting upon, so that a particular step or an action of a work system is carried out. So we will interpret that what is the stimulus, what we are prompted to do, so that the next step gets the output from our side, and then we do a situation assessment, okay. And then based on that we can have a plan and an intention of action. So this is the cognitive part of the worker component which is involved in such work systems, that whenever there is such a stimulus that I want to start doing this activity or this work just because I got the material from the last step, or let us say I got the resources or a command from the last step. So you first interpret that command and assess what is the situation that you are in and what you need to do, or what is your intention of or intended plan of action for the next step. And so you basically plan out and also draw out an intent of acting upon, so that you can have a action by executing the action, okay. So in process of doing it, you use a lot of external cognitive sources. For example, there is a memory of a concerned subject which is involved in it. So have you done anything prior of this type? So the person, the human brain, will take a decision based on that. If somebody has done something earlier and is in memory, we can think of putting this memory back into into place. And so there may be some lapses and errors based on such memory. There also can be a sort of a mistake, because the knowledge that the concerned operator had about assessing the situation and interpreting what you have to do may be inappropriate, or the rule that he applied to do it also may be inappropriate because of lack of knowledge, and there can be many slips on the way. So I will probably come and explain this concept a little in a little more details probably in the later on lecture. So today I am going to close this lecture here, and the next lecture take up again from taxonomy of human errors and try to explain the different other causes of errors, like errors related to job methods as well as environmental impacts. So thank you very much.